Welcome to EDU World Space.
Okay, so we're doing chapter 34, problem 41. So this one's going to be talking about the combination of lenses, as we can see here. So we start out with an object of 1.2 centimeters tall, and we place it 50 centimeters to the left of a converging lens. So let me just place that right here. So call that S1 equals 50 centimeters. And this first lens, is a focal length of 40 centimeters. So f1 equals 40. Okay, so we have a second converging lens with a focal length of 60 centimeters, placed 300 centimeters to the right of the first one. Awesome. So, cool. So part A. We want to figure out the location and height of the image formed from the first lens. Cool. So we can rearrange the thin lens equation as we do always, solve for what the image location is. We'll call it S1 because it's from the first lens. So S1 prime is S1 F1 over S1 minus F1. So let's start plugging that in. So this is 50 times 40 over 50 minus 40. And we should see that that comes out to being 200 centimeters. So let's go ahead and mark this as I1, and this is 200 centimeters away. Cool. So that means this distance right here is going to be S2, and now we know it's going to be 100 centimeters. Cool. But let's finish this one, part A. So this is S1 prime. So now we need to figure out the height. So we know that the magnification is negative S prime over S, but this is also Y prime over Y. So from this, we can solve for Y prime being negative S prime Y over S. So this is negative 200 times 1.2 all over 50. So this becomes negative 4.8 centimeters, or 4.8 centimeters tall. Cool. So now part B asks us to use the image from the first lens as the object for the second lens, which is how we combine and find the resulting of a lens system. So in that case, we know that this is just going to be S1 prime F2 S1 prime minus F2. Awesome. So this is 200. Oop, my bad. This isn't quite S1 prime, right? Because of where the lens is. S1 prime is 200 to the right of the first lens, but that's equivalent to 100 left of the left lens. So let's roll this back a little bit and call this S2 because they are actually different as I wrote up there. So F2 for S2 minus F2. So yeah, we can see here that S2 is going to be 100. So this is 100 times 60 over 100 minus 60. And this equals 150 centimeters. Cool. So now we just got to find out the height of the last image. So again, we can use this equation, but we're going to have to use the height of the image before, which was negative 4.8 for y. So this is negative 150 over 100 times negative 4.8. So if we plug all that in, we see that this is 7.2 centimeters. So our final image is 7.2 centimeters. It's going to be upright because the first one is going to invert it. The second lens is going to invert it again back up to normal. Awesome.